So, okay, so we did the hello. So I want to, before I start the meetup, I just want to do a quick survey as a show of hands. How many people have know about Predix or have used Predix here? Okay, that sounds about GE team. Okay, so I'm going to skip the time series question, given the Predix, not a lot of people know Predix. So how many people have used Apex here? Okay, that looks like the Apex team. So, okay. Okay, so I think we have good content for the day today. So here is the outline for the day. So we're going to talk about what Predix platform is, give a high-level overview of what we are trying to do here. We're going to talk about what Predix time series does as a service in Predix platform. Talk about Apex a little bit to introduce to folks who've not known. Just talk about stream processing in general and like what are our journey with Apex and some best practices around it. Towards the end, there's going to be a demo and a Q&A. Okay, so Predix platform. So it's a cloud-based platform for industrial IoT. So an example of an IoT application would be, let's say, a predictive maintenance application. So it's an application that constantly monitors probably an asset. An asset in most of our cases are like very big machines. And then trying to predict if you have to do maintenance on the machine itself proactively. So what happens is if you don't predict and if it becomes an unplanned outage, there is a lot of cost involved. So that's one of the use cases that people try to solve. There are also other use cases around asset optimization to get the best out of your assets. So yeah, there are several use cases like that. The platform is built on top of Cloud Foundry. So if you're not aware, Cloud Foundry is an open source PaaS system. It has got a vibrant community around it. GE has a set of core engineers that actually work and contribute on Cloud Foundry itself. The platform, the Predix platform provides a rich set of services. So if you're an industrial developer, you don't have to necessarily work on all the scaffold services and stuff like that. The platform offers you all of those by default. So you can get that going and then start to work on the real problem that you're trying to solve. I mean, as a PaaS platform, of course, everything is managed, the infrastructure is managed, the security is provided, and there is also a marketplace. I think someone earlier here was just mentioning about a marketplace that's there in Predix. So if you have your own service, your own idea, you could basically put it on Predix and then monetize it. Okay. This is okay, it is not much there. Okay, so this is an interesting picture that actually shows the type of user that we deal with. So this is not a traditional IT environment. Folks, so the data that we have to present to these folks will have to be based on the environment that these guys are operating on. It probably has to be specific to the asset that they are working on and the environment around it. So this is like our user base. Okay, so here is the architecture of Predix. If you see at a high level, there are a few components that I want to highlight. So there is a wind turbine on the left, of course. There is an application on the right, which actually gives you a broader perspective of what's going on. But what's in between is what Predix is all about. So there is a Predix machine component, which is almost like a runtime that gets deployed on the edge. Sorry. Okay. That gets deployed on the edge. What it does is it constantly monitors the asset sensors and then does some analytics locally and then gives the feedback back to the turbine. What it can also do is it can use the connectivity as a service to send it to the cloud. So we do have a service that can essentially use a local cellular network in some case, satellite-based network in some cases, and some cases dedicated networks to connect to the cloud itself. So, and on the cloud, we have our infrastructure that's carved out for operating on industrial workloads. We've talked about Cloud Foundry. On top of it, we've built a bunch of microservices. So there is an operational service that gives you ability to do DevOps as a service. There is one that actually gives you BizOps as a service. That means if you want to monetize your service, you could use that to operationalize. So the data portion is where we come in. It's a part of our team. So we build foundational data services for all of the Predix platform. There is, okay, sorry. Okay, here. Yeah, click on unclick. Yep. Okay. Okay. Sorry, we kind of moved beyond. So then there is asset service, which provides you a way to model your assets, their relationship, their sensors, and stuff around it. And of course, there is an analytics service. What good it is to just have the data without doing analytics. So the service gives you an ability to orchestrate analytics, and there is a catalog where we have all of our algorithms and stuff like that. So who we are as a team. So we are data services here. We love Go. We also love Java when we do Apex and other systems. We work on distributed systems and big data and streaming data systems. So if you guys have worked on similar technologies, please feel free to reach out. Vinata, she's there somewhere out there. Okay, there she is. Okay, so I want to quickly give you an introduction about Predix time series. So, I mean, at the end of the day, time series, it's a service to store time series data and retrieve. But what we actually do is industrial time series are slightly different. In the essence, for example, the picture that you see on the side gives you a quick overview of what a time series data looks like. So there is a tag. Tags are typically sensors that you essentially measure something. And there is for each of the timestamp, there are two elements to it. One is the measurement itself. I mean, what do you measure and what's the quality of the data? So quality is pretty unique to industrial use cases. So what quality tells us is what's the context in which the data was generated. I mean, is it a good, is it a bad one, or like what do we have to do with it when we run analytics? So our service kind of actually gives you ability to store all of this. There is also attributes which gives you context around what the data points is generated. So all of those are there. We do support millisecond level precision and have support for strings and numbers. Okay, waiting for the screen to refresh. Okay. Okay. Let me figure out. Okay, there you go. So, so this is the overall architecture of Predix time series. So there are, on the left-hand side, you see multiple sites with like various machines. There are data getting generated. It could be sensor information. All of those actually goes to a cloud gateway, which is written on Go. It's high performance. So it takes the data. All it actually does is it puts it in a distributed messaging layer. So we use Kafka here, and then the pipeline actually picks up the data. So a pipeline is powered by Apex. So we've done a bunch of changes around it. We're going to talk about what we've done and stuff like that. So eventually, the data goes to our low latency columnar store. That's a proprietary store that we have. And then there is a query service that's actually reading the data off of that and sending it back. Okay, so next time I'm going to click the button and then keep talking. Okay. There is something definitely wrong. Yeah, it's changing here, but it just doesn't reflect
Can I
that.
ask you a question?
Sure.
One of the things that you had on your time series that I thought was missing is you normally, if you're going to do, say, batch or even continuous processing in a factory,
Okay.
you have to understand the machine, what the machine is,
Okay.
the time stamp for that machine, so you can go through the process and then look at that time series, the time data for each of the steps, that's gone in between the machines. I don't want to. So when I look at your slides, I don't see where you're showing, I can see when you have a windmill or something like that, they're not, there's not a continuous process flow or batch process flow. It's just a machine that you're recording, or a jet engine is the same thing. But if you're going to do that in a factory, you're going to have to also have some other data, information recorded so that you can look at this data and provide predictive maintenance or analytics on it.
Absolutely. So I think there is a combination of things that was going on in the picture. One is local analytics that actually happens on the factory itself. Like, it could be an edge-based device like Predix machine that actually takes these data as it streams and then provides feedback back to that. but you do want to look at some of these assets at a very higher level, so you can basically optimize it at probably wind farm level. So for those data, all those data actually goes to the Predix cloud, and Predix cloud is where the analytics is actually run. And that's run by a data scientist probably working on and looking at each of these asset types and optimizing the asset.
So, and one other question, on one of your other slides, if you go back a few, I don't know, you can't just go back.
Okay, yeah. So that's where
the one slide where you said this is Predix, where you said, there's like, is that a Predix gateway that you're talking about? You have the wind farm, you have the windmill, there's a Predix gateway.
Correct, yep.
And that Predix gateway may not send any data back up to the cloud. It may actually
so the
have
gateway
data
is
sent down to it, right?
Yeah, so the gateway is running in the cloud itself. So what happens within Predix machine is not something that we are completely covering in this talk. And this talk is more about the time series service that is available in the cloud. So the gateway that you actually saw is in the cloud itself.
So there's no time series locally at the gateway level.
So GE has a time series data store called Prophecy Historian. That's been there like for a couple of decades now, and it's already deployed in so many different places. So that is still relevant for whatever we are doing. And there is also future work that are happening around taking Predix and putting it in a box on the site itself. So that's a separate thing. Okay. Yeah.
What all analytic capabilities Predix offers out of the box?
So I'm not going to go very deep around the type of algorithms that are available, because there is a catalog and it actually offers a wide set of algorithms. So I think it'll be prudent for anyone to actually go and look at the catalog itself, in my opinion. Sorry, yeah. Okay, awesome. So, okay, now that this is there, so there are a few, time series supports an API, and the API actually offers a bunch of different features. So, in industrial use cases, not all the data are sent to the cloud. So, because the data are sometimes like just too heavy, and sometimes they cannot be generated because they are affected by other issues. So, interpolation is a big thing. So, we do support interpolation. There are all standard aggregations that we support. You could filter based on attributes, quality, values, and we do support limits and order by if you're looking at doing analytics. Okay, so if you want to use Predix time series, the quickest way is sign up on predix.io, and then you can create an instance and bind to an application. So that's the quickest way. So when you bind to an application, you get the credentials for accessing the time series, and then you can start pumping the data. Okay, so this is a quick introduction to Apache Apex itself. So Apex is a streaming analytics platform, stream processing platform. It provides event-based low latency processing. It also does some sort of windowing. We're going to talk about it more from a bookkeeping or a reconciliation standpoint. The platform itself is scalable and highly available. One of the features that I like from Apex a lot is the state management. So what you could essentially do is you could put a few more properties or a context on the operators themselves, and what Apex can automatically do is checkpoint at different intervals to save the data on a disk, and it can restore them back if in case one of the operator goes down. So that's pretty cool. And then there is a wide set of pre-built operators that are available on Malhar. So if you have a simple application that you're building, it comes pretty handy. This is the platform architecture for Apex. Okay, so I'm going to move to the next one.
Hey, one question. In the cloud picture that you showed, where does Apex fit in? I could not see anything.
So the pipeline is where the Apex fits in. So all of the pipeline processing that is happening is powered by Apex. So
everything after Kafka is
everything.
Apex.
Yeah, correct. There are a few other things that also happens, but this is a simplistic view of the service here. Okay, so I'm going to press the next one before okay. So what you're actually seeing here is HDFS. So Apex is natively running as a yarn application. So what you see on the bottom is Hadoop. It uses HDFS for checkpointing, so that's where the state source, so it runs there. streaming runtime or STRAM is the application master that kind of manages your application itself when you launch the streaming application. So it does heartbeats between each of the operators or the processing units that is running on the streaming application, and then kind of controls and manages the life cycle of it. So it went too soon, sorry. So that's all right. So so on top of it was streaming application. That's effectively what we deploy. So it's our application that we built, and there is also Malha that we talked about, which is the open source operator library that you can essentially utilize to build your own stuff. Data Torrent has a few other things like the management console, visualization board, and a designer. From a GE's perspective, we actually only use management console, although the others might also be useful. So the management console gives you ability to look at the logs across. It's a distributed application at the end of the day, so you need to be able to look at logs across multiple instances and stuff. So management console is pretty useful from that perspective. The REST API on the side, which is horizontally cutting, is pretty useful too. This time it was too quick. Okay, so the REST API, what it actually does is, so for all of our automation, deployment automation, monitoring, we use the REST APIs. So it comes pretty handy. This is, if you're new to stream processing, this one slide is effectively giving a quick introduction of what stream processing is. So the entire picture, the rectangle that you see is called a DAG, a directed acyclic graph, and each of those nodes are operators. There is an input operator on the left hand side, the output operator on the other side, and there are operators in between that is doing some sort of a processing. So in this case, what we are doing is we are probably computing a top K, an example of top K engine with a high or low oil pressure. So the event reader is taking the stream, splitting the stream based on probably an engine type, and then sending it to multiple operators. These operators are probably only looking at oil pressure events and probably like dropping all the other events. So what we are doing is we are then sending the data to a top K operator, which let's say uses some stochastic algorithm to figure out what the top K is, and then uses that, and then the data store writer just writes the data. That's the whole idea. Okay. Sorry, going to go. Can we just launch it in your application and then we can get back? Yeah, pretty much so. Okay, I think the next is a quick introduction about windowing. So, I mean, in a stream processing application, you need to reconcile events that have been processed by each operator or each operator instance. So if in case of failures, you can go back and restart from where you last processed. So instead of doing it at every event, because it becomes too much of overhead for the application, so what typically these systems do is they create an event window and then like operate on the window itself. So what Apex does is it actually puts a marker operator as begin window and end window, and then like sends the data across these operator instances. So there is also a concept of checkpointing happens after like a set of system event windows. So so what happens is if a particular operator goes down, what it does is it goes back to the previously checkpointed window and then starts from reprocessing all the streams. There is also application window. This is helpful for application writers, like if you build, let's say, a sliding window algorithm. So you could use the application window to say, I want to look at windows at these intervals. So it automatically, the platform actually lets you know when the sliding window essentially reaches, so you can do your computes and stuff like that. Okay, this is much better. Okay, this is a simple code of how a streaming application would look in Apex. So this is a word counter. So there is a stream of lines that is coming in. Another operator is just parsing each of the lines to emit words. And there is a counter operator which counts the number of unique words and then writes it to a console. So if you look at the code, I think the code is like, 7 lines. So there is 4 lines for defining each of those operators. So there is like, we define each one of those operators. And then the next 3 lines is for each of these lines, right? The streams essentially between. So it basically, the first line actually says, I'm adding a stream for lines, reading from this input operator, and then putting it to the, reading from the output of this operator to the input of this operator. That's the whole idea. So why we choose Apex? So there are a few reasons. So one is from an operational standpoint, the yarn compatibility is pretty helpful for us. We already have a data lake with all the data there. So being able to reuse the compute and the nodes around it is pretty helpful for us. The platform is pretty fault tolerant and stable. Even though it's actually a new project for Apache, it's been there in production and battle tested for a while. I think it's in 2012, right? I'm assuming. Okay. The APIs gives you a way to quickly deploy and stuff like that. So that is pretty helpful for us to do automation and do scannings and other stuffs. All of our clusters are Kerberos, so that also is a pretty important thing for us. From a developer standpoint, I think the key things are the Malhar, the operators that are available, and being able to dynamically partition. For example, in Kafka's use case, right? So when you have the number of Kafka partitions, I mean, if you want to dynamically increase the number of Kafka partitions, you could, and then what will the operator there would do is it will automatically create enough instances for the Kafka operator, for each of the partitions, so to process those. So things like that. So, and based on the load also, you could actually add more operator instances, so you can partition the data and add more operator instances. So that also is pretty helpful. In general, because it's a event-based architecture, the performance is pretty good. Okay. So now I need to show a skimmed version of the DAG. So can you switch? Yep. This is the time to switch. Okay. Okay. So this is a subset of our pipeline. So this actually gives you a few different things here. So this is an application, demo application that's actually running. So it actually has a stream source, which is actually reading off of the Kafka in our case. And then there is a parser operator. I mean, because we can actually have various types of data, time series data coming in with using different formats and stuff, we do have an operator which actually makes a semantic sense out of the data coming in. And then there are a few other operators. So one is the sync, which is actually writing it to our data store. There is an error sync. If there are problems in parsing, we actually put it in another topic. There is a usage monitoring. So for us to essentially know how much data each consumers are consuming. So so that's like, so if you look at the console itself, it actually provides a few other information which is pretty helpful. So you can actually see how many events are processed, what's the latency of the system itself, and how many got emitted across each of the operators and so forth. So if you go down, you can actually see here information about each of those operator instances and what they're doing. Okay. Okay. So okay. Okay. So I'm going to keep it smaller because I have a feeling if you do it smaller, it's much faster. Okay. So, so we're going to quickly talk about partitioning strategies and how we do partitioning. So the DAG that you just saw, we'll actually talk about how we do partitioning the moment we kind of go over these. So, so what Apex does internally is when you construct a logical DAG and then like deploy the application, launch the app, it goes through the DAG and figures out how many instances of each of those operators needs to be created and how it needs to be stitched. And accordingly, it goes and gets all the containers from yarn, resource master, and then deploys the operators there and then stitches them together. So in this case, there is a logical DAG which actually gets the data here and does some deduction and then puts the data out. So what we are actually doing is the deduction operator is running on multiple instances, so automatically Apex can essentially spray the data out, and then it can also add an operator called unifier operator, which is kind of consolidate all these data from various operators into this one operator. So that's helpful when you have to reduce the number of partitions to like a single node. So how does stream split work? So the simplest use case is it basically looks at the tuples and then does a hash code on that and then uses a few bits in the end. It's typically a log n number of bits of the number of partitions, and then figures out based on that which partition that the data got has to be mapped to. It's a simple algorithm, nothing fancy.
Venkatesh, a question.
Okay.
So the difference between logical and physical DAG is only the unifier operator.
So, oh, it's a question. Okay. So, yeah. So there are a few things going on here. So one is the deduction operator. I mean, like if you have to have a single operator running on multiple instances, so the partition automatically happens. So that's happening. The unifier operator is just a way to unify the streams down. So it's a simple use case that I've taken here to explain this. Yeah, it can get really crazy sometimes. So the hash code is one. So if you don't want to have this, use this default hash code based partitioning, you could actually implement your own stream codec. Stream codec is an interface that you can implement and then provide a custom hash code algorithm that you could essentially use to change the partitioning logic. If you don't want use the hash code algorithm at all, you could also write your own custom partitioner and define what your partitions are going to be, what your states that needs to be handed over to each of those partitions. So the next one is the M/N partitioning. So this can be the same use case. For example, the same logical DAG that we saw could also be partitioned like this. So there could be m number of input operators going to n number of the detection operator, and then like it can essentially stitch together and then do the processing. To enable this, you just have to enable that config, the stateless partitioner to whatever number you want for that particular operator, and then it'll automatically spawn those instances across containers. So the next one is going to be parallel partitioning. So in this case, you could actually say, I want to actually have as many detection operators as the same as the number of input operators that actually gets created. So what it'll automatically do is it'll actually look at the previous operators, see how it's stitched, and accordingly create the number of instances. So I think we briefly talked about unifiers. So unifiers helps to combine outputs of multiple partitions into one. It can come pretty handy if you are trying to unify a large volume of data and into like one operator instance where you're doing some sort of a max or a sorting or something like that. So in this case, what it can actually do is it can have multiple levels of unifiers, which can actually get the stream down to really a single one. We're just talking briefly more about the custom partitioning. So an example of a place where we have used custom partitioning is it's actually Kafka. So what in Kafka, I mean, like I actually mentioned, what happens in the Kafka's use case is the number of Kafka partitions is going to determine the number of partitions that you're going to create. So and then it can also dynamically repartition if the number of Kafka partitions actually change. So that's actually using a custom partitioner. So if you want to take a look at that, you can look at the Kafka streaming source operator. Okay. Now I want to take this back to the UI. Okay, still taking time to. As the time progresses, the performance. Yeah, completely directly proportional. Okay, so this is the DAG that we looked at. So if you go to the physical DAG, so what you see here is how this logical DAG has gotten deployed on the instance. So if you look at this, there is a bunch of streaming source that are there. So and each of those streams, so in this case I have a topic that has about 8 partitions. So what it actually does is it has created 8 operator instances, and then it has created equal number of parser operators in the next. I mean, there is an m/n in the first case where it basically takes the 8 and then does the 7 of the second operator, and then there is a parallel partitioning between the parser and the time series thing. So kind of actually it's a simple example, but the kind of combines all of those partitioning strategies into one.
Okay, there are some questions.
Okay.
So 3 threads in parallel processing, would that be 3 detection operators separately?
3 threads in parallel processing would be 3 detection operators separately.
I guess the question is, if there are 3 partitions, are they 3 different processes that are running?
Correct. Yeah. So I mean, these things are configurable as well. So in some cases, you do want to have it running on separate containers. So you essentially like partition it and have them running on individual containers. But if you don't want to run it as individual containers, you want to run everything locally, there is a separate mode that you can operate on. And then what it'll do is it'll basically stitch those together in the same container. That might be what you want to do in many cases, because otherwise you're just throwing away containers to like one thing that you're doing pretty much. So I want to talk about a few problems that we encountered along the way, and then like this kind of solution that we had to come up with. So one was most of the checkpointing is happening at an application is tied to the application ID. An application ID is generated by Yarn. It's a Yarn's application ID. The context is around it. So what happens is, if in case you want to, so across upgrades, let's say you have an application version 1 that is running, and then it has checkpointed all of its in application ID 1. When you actually upgrade the application, and then if you have changes in your model, right, you cannot read the same state, the checkpoints that you have already done, right? So in this case, what we had to do is essentially take the state outside of the regular checkpointing scheme, and then take it out and put it in Zookeeper in some cases HDFS. So that actually helps to keep the state beyond upgrades of applications. So this is something to keep in mind, because otherwise you would essentially, sometimes you'll have to go back and reprocess all the old data. So that might not be what you want. The second thing was Kafka source. When we originally started working, Kafka source was just committing the message and offset as committed as soon as it reads the message. So it won't wait for the entire DAG to have processed the message. So what happens in that case is, let's say if the DAG goes down for whatever reason, you essentially lose the message. So you won't be able to go back to the message. So what we did is we worked with Data Torrent and the community to actually make those fixes on the Kafka source themselves. Now what the Kafka source actually only commits it only after the entire DAG has processed the message. What we also do is, in addition to like checkpointing there locally, we've also taken the offset and put it in Zookeeper. So when we actually do restarts and stuff like that, we'll always go back to what we've already processed.
So yes. The Kafka source is all the way at the edge, right?
The Kafka's no, so the edge has its own mechanism for doing analytics. So that's actually built within Predix machine itself. So the edge, after it does whatever it does on the edge, so it'll send the data to the cloud. And in the cloud, the first component that actually picks up the data is our gateway, right? So there is no Apex pipeline or anything yet. So the data actually goes to our distributed message bus, only then the pipeline actually comes into picture. So all of this happens only in the cloud.
What do you use for transporting the message all the way from the edge till it hits your cloud? Do you use any kind of message broker there, or? So
our Predix machine actually has a store and forward mechanism in it. So Predix machine is something that we have built. So it has a store and forward capability built inside that. So we use that to essentially do the staging there. Okay. So the next one is gracefully stopping DAG during upgrade. So let's say in your DAG, one of your external systems is cannot handle duplicates, or it's not idempotent, right? So in that case, and you want to be as close to being exactly once. So what you have to do is, what we have done over the course of all of our DAGs is, in the first the source operator that actually takes the data, we've added this mute property. So what you could actually do is, before you upgrade, you could actually mute the source getting any data into the DAG itself. So whatever messages that are getting, tuples that are getting processed, it will completely go through the DAG and it will kind of drain. We'll give it a minute and then do the upgrade. So that way there is, like all of these other systems, we don't have to worry about duplicates on these other systems and other stuffs. So the last one is event time-based processing. As the event is coming, there is only the time that we have received the message to the pipeline, right? There is no, so the time in which the event was emitted, right? And if you're doing aggregations or any processing based on the time of the event was generated, there was no out-of-the-box solution. So what we actually did is we built a bunch of data structures called spooling data structures that actually do some state management behind the scenes. So what you would essentially do is you would use those to essentially keep all of your maps and aggregates essentially in memory, but backed by disk. and then do your processing. So if in case a particular event arrives late, you can go back there and pick up the data and then process it. So we are in the process of open sourcing that. Yep, that's happening pretty soon. Okay, so this is my last slide around the key takeaways. I think over the course of time, I've kind of alluded about upgradability, tolerance for failure a few different times. I think it is pretty critical in a streaming applications to just make sure. So Apex automatically takes care of situations where operators goes down, because it'll know that the operator has gone down, it'll reinstantiate them in another place. But what happens if the STAM itself goes down? So there are other scenarios that you have to think through and then make sure that it's completely available. Monitoring DAG for failures, yeah, so we have to do that. And then static partitioning helps only so much. So there are many cases where you have to do dynamic partitioning, especially in industrial cases where the loads are completely like dependent upon time, for example. So in some cases, the machines are going to send a lot of data to the cloud, and all of a sudden there will be no data at all. So and then after some time there will be more data. So you'll have to plan for that. So continuous integration and deployment automation, in my opinion. So the APIs that Apex has is pretty handy for doing all of this. Performance testing and benchmarking. So like I said, throwing new containers at an operator is not a great idea, because you're effectively like wasting a lot of resource. So doing performance testing and optimizing each of those operators are pretty critical. Ship and store logs. I mean, using Yarn, there is Yarn log aggregators, so you should use the log aggregators. I mean, if you do have a data torrent license, there is a console that you could essentially use and get the data out. But yeah, definitely having Yarn aggregator on is pretty important. Okay, so I'm going to hand it over to Pramod.